And once again, problem number 6, problem number 7, we're 8 not able to do. 9 we could do. On the back, 10, 11 we could do, 12 we could do, 13 we could do, 14 and 15. We'll talk about 14 and 15 today. So some of them you're able to do, some of them are not. That's fine. If we take a look at problem number 4. Once again, this is a challenge. This is a challenge to your knowledge of exponents and some algebraic skills. First off, we have to remember our definition if we have a rational exponent x to the a over b. This gives us the bth root of x to the a power. The denominator is your root, and your numerator is your exponent to the term. So looking at that, and then also if I have x to the negative a, this is 1 over x to the a, and 1 over x to the negative a will equal x to the a power. These are also properties of exponents that we should remember from our algebraic days. Back when we were studying Francois Viet. Francois Viet is the father of algebra. So if we take a look at these tools now, well, if I have 7th root of x to the 4th, what would be the exponent to that, Ozzy? X to the 4/7 power. Now what we need to get this into is we need to get this in the form of f of x is equal to a times x to the nth power. And n can be any value. Okay, so we have now it in the bottom, and we have to bring it up top. To bring it from the bottom to the top, we have to make it a negative exponent. So f of x is equal to negative 21 x to the negative 4/7 power. Now we can apply the exponent rule for derivatives. Applying the exponent rule for derivatives. We have the exponent comes out front, negative 4/7. And then we subtract 1 from our exponent. Okay, I'm slowing the process down right now. Okay, so you can just apply the product or the exponent rule. So I'm just taking a times n, x to the n minus 1 power. Simplifying this, we have negative 21 times negative 4/7. Hopefully we can see we can cancel 1 and negative 3. So we have negative 3 times negative 4, which gives us positive 12. Now we have negative 4/7 minus 1, which is negative 4/7 minus 7/7, which is your value of 1. So we have negative 11/7. Taking it back down into the bottom, this is 12 over x to the 11/7 power. Now we need to get this into a simplified radical form. A simplified radical form. If I'm in a rational exponent here, I look to simplify make my exponent a mixed number if it's in a proper fraction. if I had x to the 11 over 7th power, 11 over 7, we can write that how as a mixed number? Liam? How can I write that as a mixed number? 11 sevenths. Huh? 1. And the key word he said between the 1, the 4 sevenths is the word and. 1 and 4 sevenths. 1 and 4 sevenths. What mathematical operation goes with the word and? 5 and 4 equals 9. 7 and 3 equals 10. Nate?
Addition.
Addition. So what we have here is we have addition, which now we can use our exponent rule for multiplication that we talked about yesterday. If I had x to the a times x to the b, this is x to the a plus b. Well, putting this process in reverse, I have the 1 as my a, 4 sevenths is my b. So this would give us x to the 1 times x to the 4 sevenths power. Which takes us back to x 7th root of x to the 4th. So my solution is 12 over x 7th root of x to the 4th. Now, if you want to take 11 sevenths and say this is the 7th root of x to the 11th, and you know how to simplify that and break that down, if that's a little bit easier for you, that would be fine. This would be x to the 7th. X to the 7th times x to the 4th. Once again, I can add these two together to get 11, which is the 7th root of x to the 7th times the 7th root of x to the 4th. So we have x to the 1st times 7th root of x to the 4th. Whatever works for you is fine. If I'm already in an improper fraction, I just change it into a mixed number and simplify it. If we had x to the 22/5 power, I need to simplify this down. Changing it into a mixed number. 22/5 is a mixed number as what, Evan?
4 2/5.
Yeah, this is x to the 4 and 2/5 power, which gives us x to the 4th times the 5th root of x squared. A lot easier, because it's easy to do get a mixed number out of an improper fraction. You've been there, done that since maybe even 4th and 5th grade. You change an improper fraction into a mixed number back into improper fraction. You've been doing that a long time. So why don't you utilize some of your old school technique and be able to simplify it down rather than saying, okay, I have to change this into a multiple of 5. So let's see, that would be the 5th root of x to the 22nd, which is the 5th root of x to the 20th times x squared, because I have to get a multiple of 5 to get my root there. If you take a look at problem number 9, we have 7 over 9 x to the 5th. I could just rewrite this as a mixed, I could just take this out front or take it up top. So I have 7/9 x to the negative 5th power. Now I can apply my rule. Take my negative 5 times 7/9, negative 35/9. Subtract 1, so we have minus 6. And a lot of times what I'll see on tests or worksheets is just throw the -1 up there. So you have -5, -1. So you don't have to write that additional step. So we have -35 over 9. And this x of -6 will drop back down to the bottom. So we have -35 over 9x to the 6. And problem number 11 you can do, but you have to utilize your definition. You can go back to old school. We have, let's see, the limit as x approaches 2 of f of x minus f at 2 over x minus 2. So we have, let's see, x over x minus 1 minus f at 2. Let's see, that would be 2 over 1. So we have a value of 2 over x minus 2. So we have 2 here, and then we have 2 minus 1, which is the value of 2. Multiplying through by x minus 1, x minus 1. You can always go back to definition to be able to find derivatives. X minus 1's cancel when I multiply through. So we're left with x minus 2, x minus 1 over x minus 2, x minus 1. Don't be tempted to cancel out the x minus 2 there. This is a -2x plus 2. Just have some patience. So we have -x plus 2 on top. X minus 2, x minus 1. Factor out your -1. So the x minus 2's, they go bye-bye. So we have -1 over 1, 2 minus 1, which is a value of -1. You can always go back old school method. Once again, this will challenge you in regards to some of your applications of exponents. And as I talked to you about calculus at the beginning, when you're talking about calculus, it is a culmination of all the things that you have learned through your algebraic career, through your mathematical career, and you just start applying all those different things. Okay, so that's, going back and going through some of that old school mixed number stuff. That's stuff that you did 10 years ago, or 7 years ago. You didn't do it in second grade. So, I mean, it's just a combination of everything that we've done up till now. Going through just 2 different problems here. Find the equation of the tangent line of the graph of the function at x equals 2. Well, to find an equation of a line, a tangent line, I need to utilize my point slope equation, mx minus x1 equal y minus y1, which means I need to know a point and I need to know a slope. Well, the point is the point of tangency. which I know my x value is a value of 2. That is my point of tangency. Well, what I'm trying to do is find a point at which I'm going to just touch the graph of this function. The graph of this function. And I want to just touch the graph of this function at x equals 2. Which means I need to find the y value that corresponds to that, because there's an x and a y value. So we can find our function value at 2 by plugging in. So we have 6 times 8 minus 5 times 4 plus 2 times 2 minus 7 to find a point of tangency. Carmela, what do you come up with? 25. And once again, this is your point of tangency. My point of tangency. That's my x and my y value here. The next thing I need to do is I need to find the slope of the tangent line. Well, the slope of the tangent line, once again, another way of stating the slope of the tangent line is the value of the derivative at that value of x. What's the value of the derivative at that specific value? So what we need to find is we need to find our slope, which is the value of our derivative at 2. Well, if I wanted to, I could go in and say the limit as x approaches 2 of f of x minus f at 2, which is 25 over x minus 2, be able to combine all those together and be able to calculate my, and then sub in, factor cancel sub, and get my slope. Or I can just now look at my derivative. If I have the polynomial 6x cubed minus 5x squared plus 2x minus 7, and I want to calculate the derivative, I want to use my exponent rule. Brandon, what do you have?
It would be 18x squared, and then it'd be negative 10x, and then it would be just 2 and 0.
Okay, so there's my derivative. So to find my slope at this value of 2, I can just find my f prime at 2. So now I can plug 2 into my derivative. So we have 18, 2 squared minus 10 times 2 plus 20, or plus 2. Liam, what do you come up with?
94.
94. Four times 18 minus 20 plus 2. 72 minus 20. 52, 54.
I put in plus 10, that's why.
You get 54.
54.
So that is the slope of my tangent line. So now I can put into my point slope, 54, x minus 2 is equal to y minus 25. 54x minus 108 equals y minus 25. So y would equal 54x plus 78 minus 78? Maybe? No. 83? Is that better? Is that correct? When you talk about a normal to a curve, a normal to a curve, it's a line that is perpendicular to the tangent of the curve at a specific value of x. So if we take a look we look at some curve, we take a value of x, here's my value of x, here's my point of tangency, here's my tangent line, what a normal is at this point of tangency, we go perpendicular to the tangent line. So this is a normal to a curve. You look at the point of tangency, you draw your point of tangency, you go perpendicular to that point of tangency. Or at the point of tangency to the tangent line. Well, here's the exact same problem, but I want to determine the normal now. Well, what we have to go back and recall is a slope. How do we find the slope? I still have my same point of tangency. I still have my same point, which is 2 and 25. How do I find the slope? Well, my slope here is perpendicular to the tangent line. So my tangent line slope is equal to 25. How do I find my normal slope? Well, what are perpendicular slopes? Ozzy? That. What's the first word you put with that? Positive? Opposite reciprocal. They are opposite reciprocals. When you have perpendicular slopes, they are opposite reciprocals. Well, I have 25. If I make that the reciprocal, I have 1 over 25, and we throw a negative in with that. And that would give me my opposite reciprocal. So we have negative 1 over 25, x minus 2 is equal to y minus 25. So we have, let's see, multiplying by 25, 25, did I do something up?
The slope's 54, this point was 25.
Hmm?
The slope was 54, the point was 25.
Oh, I screwed that up, didn't I? Slope was 54. So we have 54 there. negative 1 over 54 there, 54 there, 54 there. You should now be able to do the last couple problems. Once again, there's gonna be some problems on here you're not gonna be able to do right now. Tomorrow what we'll do is we'll go over, a technique that will allow you to solve the problems that you aren't able to do today. It's called the product rule and the quotient rule. We'll work on that tomorrow. Looking at Friday being an in-class assignment day and another worksheet. Monday will be a review day. Tuesday will be a quiz over derivatives, just what we've been doing here, along with the product and quotient rule. Questions? All right, rest of the time is yours.